Start recording.
You have a work email.
All right. Here is the data set. I think we did one like this the other day, but we'll do this one because it was sent in, I think, during class the other day. So write those down right quick. X and Y. In fact, I'll just do this. Let me just put it in Excel and make it big where y'all can see it. Okay, there's the numbers. So go ahead and write those numbers down. Put them in your calculator if you've got a calculator. If you've got an Excel spreadsheet, you've got your laptop, just use your laptop.
Mr. McClure?
Yes.
We can't see the board. It says connection not established.
Okay, let me send it to you again.
Okay.
All right, I just sent it to you. Did it come through?
No, we can't see anything on the board. We see your video, but that's all.
This is what happened the other day. All right, I'm going to have to take you out. If you'll X out, I'll bring you back in and I'll do it again. I'm sorry.
Okay, that's okay.
I don't know. I'll tell you in just a minute. Hold on. Let me get this figured out first. This is what happens when you don't take, as a college, when you don't take your IT, your technology, make it a priority. This is what happens. Your firewall is not updated. I can't even. What's her name? Sanford, right?
Libby Sanford.
S-A-N-D-F-O-R-D.
S-A-N-F-O-R-D.
Yeah. Okay. S-A-N. She don't have a D. That's why I couldn't find her. Okay, and it should ask her to accept because I am presenting. All right, look for the accept button. Because I am presenting, it should ask you to accept.
We see it.
Okay, you can see the...
We see the cursor moving. We see the spreadsheet.
Okay. All right, write those down, and I'll just basically tell you what's happening because I don't think I've told y'all, Oconee. Basically, the firewall for Tri-County Tech hasn't been upgraded for the last 5 or 6 years. No, they're just having problems with it. I think, to me, that's the way it was explained to me. And that's why the internet's having problems staying. We're having problems keeping the internet going on all the campuses. Found out that the money was being used for other things. That's what happens when you have leadership that don't think technology is important.
Is that why, like, for a little bit on the actual ETC website, like, I'd pull up my student bill and it would, like, it gave me, like, a really weird number that I owed money, and then later on it was, like, I actually got back money. I did too. I got back, like, almost $200 because I was, like, called financial aid. I was like, well, what's going on? Like, I don't really want to.
Yep, that's it. All right, so if you have Excel, then you just click on this and you go to Insert and you go to well, I don't know why it's blinking. Never seen it blink before. There. And there is the pattern. Of course, what do we see? We see a negative what? A negative correlation. And if you were to draw, hold on a second and I'll draw it. If you were to draw a sketch of the correlation, let's see where I would draw it. I would probably draw it, I don't know, maybe right in there somewhere. because this one kind of pulls it away. It could be closer. If it wasn't for this dot right here, you could put it pretty much down in here. But anyway, I think it may be closer. In fact, I will change it just a little bit. I'm going by eyesight, okay? So I'm going to try to impress y'all with there. Maybe right in there. I don't know. I may be off a little bit. Maybe right in there. Okay, that's what I think it is. So click on it. I'm getting there eventually. I might need a drink after this class. All right, so add trend line and go down and hit those two. And take the square root of that function. That r squared. Golly, I was close. Look at the steepness of my line and the steepness of their line. Dang old, about the same line, isn't it? Let's look and see. Oh, really? There. Look at there. I was close, wasn't I? Except it was up here. I put it up there. I over-exaggerated for this one. So, now somebody take the square root of 0.2462. What do you get? 0.5, right? So there's a good correlation. Anything above 0.5 or above is probably a good correlation. Now this is a negative correlation. So this would be like the more weight of your vehicle, what happens to your gas mileage?
Decreases.
It decreases. Okay? If you drive one of those, what does Brian Griffin drive? He drives one of those electric. Yeah, Prius. If you drive a Prius that weighs about the same as, probably 100 pounds. Okay? If you drive a Prius, then you're going to get 500 miles to the gallon. But if you drive a 3500 Dodge Ram, you only get 16 miles to the gallon. Why? Because of weight. Okay? Robbing Peter to pay Paul, and nothing is free. So, what should you need to be able to do with 4.1 and 4.2? I've told y'all this. You need to be able to find R. You need to be able to find y is equal to mx plus b. You need to be able to find the slope. You need to be able to say there's a correlation. And if this was weight of a vehicle and gas mileage, is there causality? Yes. Right? Causality means that one thing causes what? The other. Okay? Now, as far as that other stuff that they asked you on F and G and H, we're not worried about that. Just get through it on the homework, try to pick the right answers. It's not going to detriment. I'm just going to tell you, don't worry about it. I'm going to ask you on the test, you're only talking about 2 to 3 questions because it's only going to be 10-20% of your test. 4.1 and 4.2. I'm going to ask you to find the slope. I'm going to ask you to find those questions I gave you. If the slope is negative, what is the correlation going to be? Negative. Does correlation mean causality? No. Find the slope of this line. Find the trend line. What is R? Those are the 5 or 6 questions that I could ask. Okay? Don't want to spend too much time on 4.1 and 4.2 because it's only 10 to 20% of your test. Okay? But is that good? Everybody got what was important there? Okay. So let's get out of that and let's go back to the whiteboard and let's get back to whatever chapters we're on, 5 or 6. Is it 5? 5.2. 5.2, which should be the additive law, or is it continued probability? What's the title of 5.2? Somebody look on your outline and tell me, or look in your book.
The addition rule.
Yeah, it's the addition rule and then the multiplicative rule. Well, I ain't finished yet. 5.1, I ain't finished. 5.1, I want to continue with probability. And we're going to go to odds. Okay? So, We already talked about probability. We talked about the probability of an event happening is equal to the number of times something occurs over the number of times it can occur. Or the number of times it's tried, whatever you want to call it. All right? What is the probability of an event not happening? Well, what did we say that was called? Starts with a C. O. M. P. L. Complement. Thank you. That's called the complement. I don't know if it's spelled with an I or not, but I'm putting in quotation mark. That way I can spell it however I want to. The complement is 1 or the total minus the probability of an event. Okay? So if I tell you that the complement of 0.35 is what? Well, 0.35 is a decimal. So that means the highest you can go is 1. So 1 is the total. So 1 minus 0.35 is 0.65. If I tell you that 100 people are surveyed and 30 people say that they hate everybody, then what is the complement of that 30? 70. So if the context of the probability lies in what's given to you. If it's given probability, then it goes up to 1. If it gives you data, then it goes up to the total number of n, which is, like in this class, there's 7 here and there's 3 up there, so that's 10 people. Okay? 10 is n. So if I asked you, how many people are blonde? 6. How many people are not blonde? 4. That's the complement. So a lot of this, what is the probability of success? My favorite word, failure. The probability of success is probability of failure, is the complement. The probability of success will be defined in the question. If I say that you're betting that you can pull a face card out of a deck of cards, then what is success? 12 out of 52. What is not successful or failure? 40 out of 52. Capiche? You always got to figure out one thing. What is winning or what is success? We're not supposed to say winning, are we? No, we shouldn't say winning. Yeah, we can't say winning. That's racist. Okay, probability of success would be defined in the question. Probability of failure would be the complement of whatever you're given in the question. That's why it's important to read. Now, I'm going to give you an example of what I'm talking about, and this is a test question, and we're going to do 2 or 3 of them. Let me pull up Google and pull up a roulette table, because that's the question you're going to see on any standardized test. If they asked you a probability question, it's going to be, and odds, it's going to be on the roulette table. So let's find a roulette table and we'll go from there. I just make up my own roulette wheel. I don't need the table, I just need the wheel. So let's pull up, let's just do this one. Hold on, I don't have posters, and you're going to have to bear with me a minute. Now let's pull up the whiteboard. What was that?
They're doing.
Are you still with us, Oconee?
Yes,
Sure
we're.
still there. I have to ask you every 5 minutes because with Tri-County Tech Mayberry Firewall, we don't know if y'all going to be with us or not very long. All right, find the highest number on there. I think it's going to be like 36 or something. I see a 35. I'm looking for 36. Okay, there it is. Is there any number higher than 36? I don't see one. All right. Here, this is what the type question you will see. On a roulette wheel, and write this down, there are 1 through 36 spaces with 0 and double 0 being neither odd or even. A. What is the probability of an even number? Sorry about that. When I took keyboarding in high school, I was on the football team, and the whole football team was in there, so you can imagine we didn't get anything done, and I never did learn how to type. Is it one of my regrets? Yes. Is it my fault? No. It was the Russians' fault. Okay. What are the odds against winning? C. What will your take-home winnings be if you make a $500 bet on an even number? Okay, so there it is. There is the question you will see on a test or a standardized test. Now, I can tell you right now that a lot of people don't get this question right. What part do they get right? They get the easiest part. It says, what is the probability of an even number? They get that part right. They get the rest of it wrong. Why? Because they think they know how to do it. Okay, so watch it, water walkers. Okay, be careful on this. What is that noise?
It's the TV. They're trying to get the computer working.
There's someone who gained access to our computer who's working on it right now.
Oh, okay, good. Okay. Question.
Is there 36 places or 37?
There's 38.
Where's the other double zero at?
Well, don't worry about that.
Right.
The question's going to have a 0 and double 0. The picture that I pulled off of the internet don't have another double 0, but usually there's two. One's green and both of them are green. I just picked one. I should have picked one of both. But there's 36 spaces numbered 1 through 36, and 0 and double 0. Neither 0 or double 0 is odd or even. Okay? So, what do we do first? Well, we find the probability. What is the probability of winning? 1 through 36. Even, right? The even. So, that's the first thing people are confused with. What is the probability of winning? The probability of winning is right here. So, you're going to write down here, you're going to say probability of an even number. That's my winning. So, what is the probability of not winning? Well, that's going to be the complement. So, the probability of winning is going to be half of 36 is what? 18 over 38. So somebody tell me what the probability of not an even number is? Nope. 20 over 38. Remember, the complement. And that's where students get it wrong. That's the number one place that students get it wrong. They say 18 over 38 is the probability of not winning. Okay? What is the complement of 18 to 38? 20. I don't care what you think. I don't care what you want to think. You got to deal with the numbers. The complement of 18 to 38 is what? 20. Period. So, this is your probability of winning, and this is your probability of not winning or failure. I don't care what you call it. Probability of success, probability of failure. Now, your answer to A is 18 over 38. Whenever you're doing one of these problems with odds against, always keep it in fraction form. Why? Makes the math what? Easier.
So you don't count the zeros for even numbers or odd numbers?
They're always in the not. Okay? You always in the complement, not the not. They're always in the complement. There's what's remaining. Think of it like that. Don't think of it as odd or even. Think of it as what's remaining. The only thing you're concerned with is even. The rest of them is what's left. You see what I'm saying? What's left. So it might be better for you to think of the 20 as what's left. All right, now what? Well, now you got to do the odds against. So B is calculate the odds against. Anybody know the formula for the odds against? Probability of failure over the probability of success. Probability of failure over the probability of success. Therefore, probability of failure is what? And what's the probability of success? Well, when you divide by a fraction, you multiply by the what? And what happens to the 38? Will that happen all the time? Yes. That's why you need to do fractions. So you're left with 20 over 18. Or 10 over what? 9. Or 10 to 9. Or 10 colon 9. That is your odds against winning. Now let me ask you a question. If you want to make a dozen cookies, and a dozen cookies calls for 2 cups of sugar, what if you want to make 2 dozen cookies? If 2 cups of sugar makes a dozen cookies, then what do you need to do to make 2 cups? I just answered it. What do you got to do to make, or 4 cups? You got to multiply it by 2, right? What if you want to make 3 dozen cookies? You multiply 3 times 2. So would you be safe to say that you take the number of dozen divided by the dozen, and that gives you the multiplier? And you multiply by 2 or 3 or 4. What if I wanted to make 57 cookies? Well, 57 is 48 plus what? 48 plus 9, right? So that would be 4 and 9 over 12, which would be 4 and blah, blah, blah. You see what I'm getting at? To make 57 cookies, you would multiply by 4.5 or 4.5. Do you see what I'm saying? So you got to find the multiplier. What is our multiplier up here? 10 to 9. So if you make a $500 bet, what are you going to multiply by the 500? 10 over 9, Hubert. That's right, that's your multiplier. The 10 over 9, highlight that 10 over 9 and call it the multiplier, because that's basically what you're going to do with it. So somebody take your calculator. What's 10 over 9? What?
1 and 1 ninth. Oh.
1 and 1/9, isn't it? 1 point. Okay, now multiply that by 500. What do you get? I'm sorry, I can't hear mumble. What?
555.555.
Okay, 555.55, and that's C. 555.55. So that's your winnings. How much did you win? You won $55.55. Well, that sucks. Why? This is where y'all's critical thinking comes in.
You could have lost 500.
I lost 500 and only won.
You only won 55. Is that productive?
No.
No. So let's write this down. What is our odds? The odds against are very, what is 1.1? Is that high or low?
No.
When the odds against is low, the probability, well, let's look at the probability. All right? When the odds are low, the probability is usually high. Okay? So that means that the payout sucks. So what do you need? You need something where the probability is very what? Low. Las Vegas is not in the charity business. Las Vegas wants to make what? Money. So they're not going to fix where you win all the time. Okay? So let's change this. I want you, I'm going to erase all of this, and I'm going to change the question. Oconee, you still with us?
Yes.
Did they finish working on the computer?
They're not doing anything else to it for now that we see.
Okay. Well, I'll try to call it up and see if it works.
Okay.
Don't go off the air, because it
Okay.
may blow up. Now, I'm going to take the handy dandy do-jigger here. And I'm going to change this. What is the probability of number 26? All right, do that one. What is the probability of 26? So frustrating. Give y'all a second to do it. If you can't do it, then we'll just consider that what? Not success, but what? Failure. There we go. You can go home thinking that you're a failure. Yeah. So what's it like, Oconee? Y'all got it going up there now?
It won't load. We can accept the call, but it won't load anything else after that.
Okay, well, we'll just stay on there. I appreciate you using. Is that your computer, Miss Sanford?
It is.
Well, thank you for being quick on your feet.
You're welcome.
You know they're gonna beat you up outside when you go out the door.
Yeah, they might.
Because we had class because of you, so they're probably gonna beat you up.
I don't mind because I drove 30 minutes here, so.
Oh, well, I'm glad. I'm not glad you drove 30 minutes. I'm just glad that you didn't waste your time and we're having class. Thanks to Miss Sanford. Not Tri-County Mayberry Tech.
He called me, I do.
But, you know, this may be a good thing. You know what I mean? May be a good thing. May wake up some people. Some of these people that are still in 1996.
Okay. Hubert.
Yes, sir.
A call just now.
I'm sorry, what?
IT had just informed me that they had fixed it, so you tried to call just a couple minutes ago?
Yeah, you want me to call again?
Just try one more time for good measure, and then we'll know.
I just called. Did it come in?
No, just let me reopen Skype real quick.
Okay. Wait a minute, hold on. Let me try it one more time. For some reason it wasn't green when I tried it, and then it was green.
I don't think it's fixed. I'm going to get back in touch with them.
That's okay. Thank you for trying.
Yep.
It's not IT's fault. It goes beyond IT. It's not their fault. Like I said, one day Tri-County Tech will put technology up here, and when it does, it's going to be all right. We'll have training on this stuff, and we'll have meetings, Skyping with each other, and not having to go up to Pendleton every time there's a meeting. You know, stuff like that. It's real amazing. Shut up.
I didn't even realize this was a polycom class until the first day that we got here.
Well, at least you're not like one of my other students. My calculus class, she was told that she could not Skype in, that she had to drive from Columbia every day.
I would lose my mind.
I was like, you gonna pay for my gas?
The only reason she said that she basically said, I knew she was an idiot, so I didn't listen to her. Because she took my trig class, and she knew that I let people Skype in. And she said, if it wasn't for you, if it wasn't for me having that trig class, I would not have taken this class. I said, well, see, we have people that they don't even know what we're doing. We have people on campus, on the Pendleton campus, that have no idea what these polycom classes are. So I'm fighting an uphill battle, people, so y'all just bear with me.
I hate calling. Like, if I ever had a question and I had to call the office, it was not.
It wasn't good, was
like
it?
10 minutes of going around in this.
Yeah.
circle.
I send you to like.
It's almost like when you do something at Tri-County Tech, you're in 1990. I'm serious. So anyway, and I don't care. I'm not just talking about the polycom classes. I'm talking about the runaround. You get the runaround when all you need to do is Skype somebody. It just blows my mind. And then we ask our students to graduate, and they go into the real world, and what do they have out in the real world? Skype, technology. Just blows my mind. Okay, so what is the probability of success here? Probability of 26 is equal to 1 over 38, right? Therefore, the probability of not 26 is equal to 37 over 38. Now let's do the odds, excuse me. Let's do the odds against. The odds against winning, supposed to be an N in there, is going to be odds against is equal to the probability of failure over the probability of success, multiply by 38 over 1, which is 37 to what? Now multiply that by 500. Somebody give me that number. 18,500. During the Augusta Masters, there was a guy out in Las Vegas that bet on Tiger Woods winning. Anybody know this story? How much did he bet?
I can't
Was
remember.
it 56,000?
Yeah, it wasn't.
Okay, it was 56,000. I don't know what the odds were, but he pulled 1.5 million out of that bet. Okay? You could actually figure it if you did the math. But the whole point is, what is the probability of success here? Very what? Okay, I got that backwards. The odds is low. Yeah, the odds will be high when the probability is very low. So let's write that down. The odds against will be very high when the probability of winning is very what? Low. Now it's very important that you understand that. The reason it's very important that you understand that is two reasons. One is for standardized testing and for other tests, okay? Okay, that's one reason. The second reason is for you to have common sense when you go into a gambling situation, whether it be the lottery or whether it be going to Vegas or going wherever. If you go into a casino with the mentality that you've got a very high probability of winning, somebody needs to hold your money and put you in a corner, okay? Because what? You're going to be broke. The whole point, if you was to go into if I went into a gambling, and I did this in Colorado when I went up to Colorado for a math conference, so I'll never do that again. Anyway, I went into the casino and I won like $500 on blackjack, okay? And I cashed it in. Why'd you cash it in? Because I knew if I went any further, what would I do? I would lose it. Now I went in with $100. So I put that $100 in my pocket. So I won $400 and I kept it. All right? I did not play anymore. You know, when you're dealing with probability and odds, you've got to have a little bit of education. Okay? For instance, and we'll get to this when we get to counting, who is smarter? A guy that buys one lottery ticket or buys 10,000 or 1,000,000 lottery tickets? One, because the one has the same probability as the million. And when we get to 5.6 or whatever, I'll show you that. Joel Brawley, who was one of my instructors at Clemson, actually wrote a book about who is smarter, the guy that plays one hand of blackjack or the guy that plays 5 million hands of blackjack. The probability weighs out to be about the same because the probability of winning in gambling is very what? Low. It's very low. So if you go in with the mentality, let's say, I'm going to go buy me 100 lottery tickets because I got to pay the power bill this weekend. You're being foolish. Yes, you're being very foolish. And that's what you need to learn about odds against. This is a test question. You got two test questions in your notebook now. You got one where the probability is very high and one where the probability is very low. Make sure you know how to do the roulette table. Capiche? Okay.
You ever
Now.
lost in gambling?
Huh?
You ever lost a lot of money in gambling?
I've never gambled except for, just playing lottery tickets and that. And I've only been to Colorado one time, so.
I won $100 the other day.
Did you?
$10 scratch off.
Did you? Well, see, how much money did you put into it though?
$10.
Okay, that's the way you're supposed to play it.
But
You ever seen these guys that go in and buy a whole book? They're being foolish. Because that whole book could have a winner of 250,000 in it. But how likely is that? Very unlikely. Probably got a $500 winner or a $50 winner, but it's very unlikely.
I almost threw it away because I thought it was like a loss until I looked in the very corner. I didn't scratch off something and it had like a symbol. And if you get that symbol, you automatically won.
Always play the lottery where they have a reader. Never play lottery and just look on your eyes. Your eyes will fool you. Always check with the reader. It's got a reader right there, the little gun.
Yeah.
Always check one of those, because there's just some clerks that'll rip you off. Yeah, they'll turn the volume down on the. You have a winner. They'll turn that volume down, and you might win $100, and they say you're a loser, and they won't tell you. So always check with the reader. But that's my extent of gambling. That and farming. Farming is gambling, But you have a little bit of control over beef cows because you keep them until you either run out of feed or you're forced to sell them, one of the two. But
hey, did you see what they're doing with those cows? They feeding them powder and creamer.
oh yeah, they feed them M&Ms and Skittles and stuff too. Out west, out in some of those beef lots, they'll take Skittles, old Skittles or Skittles that they can't sell, and they grind them up, and all it is sugar. Cows love sugar. They'll eat sugar like crazy. Okay, so in the 5.2 and 5.3, 5.2, did you say it was the additive law? And 5.3 is the multiplicative law. Okay, additive law and the multiplicative law. Now, if you look in your book, you'll see a box with the additive law and the multiplicative law, and it will say something to the effect of the word or and. Okay, I'm going to go pull it up right quick because I know some of y'all didn't bring a book because I told y'all not to buy a book. Remember when I told you not to buy a book? Yeah, I told y'all not to bring a book to class, and I told you not to buy a book, didn't I? Yeah, and the Russians told you that too. Well, okay, I can't pull it up, but what the heck's going on? I can't even pull up tctc.mylabsplus.com. There we are. Thank you. So on page 244. Yeah. It should have on the next page somewhere, what page, 245? It should have something about the word and. Or. Let's see that one. See, that's why I don't tell you. Well, anyway, the word or and plays. Now think about it. The additive law, and there's something else you need to know about the additive law. The additive law, you need to worry about overlap. Okay? Write that down. You need to worry about overlap. Always subtract the overlap. Trying to find that page for y'all. Give me a second. What page you say it was? 244 and 245? Say again?
It says addition rule of disjunctive events.
Yeah, they use all those big words, those big statistician words, and I'm trying to
Like
find.
the inferences plus.
It'll say something about the word or and. This is what, section 5.2?
It says P parentheses E or F or G or ... equals.
Yeah, they spend a whole 2 or 3 pages doing nothing but talking about junk when all they need to
If it
do.
has or, you like add and then it
Yeah,
says
mhm.
and you multiply.
Yep, and I'm trying to find that for you so you can mark it in your.
What page is that that you're-
Okay, there it is. Just use an example. Look what it's got right there. See the word or? Okay. In the problem, it will say, let me see if it's in this example. There we go. Well, in the problem, it will say something to the effect, find the probability of blank or blank. And when you see the word or, that means you're going to use the additive law. Just write that down, because they're not going to tell you that in here, because that would be too simple. And you'd only have to go over with 1 page. I'm still trying to find, let me see if this is an example. Suppose a single card is selected from a 52. Compute the probability of the event drawn. Here we go. Prime example right here. Suppose a single card, you don't have to write it down, just read it. It's on page 247. This is what I was looking for. Suppose a single card is selected from a standard 52 card deck. Compute the probability of the event E equals drawing, or F, or. Okay, highlight that. If you got a book, highlight that little word or, because that tells you you're going to use the additive law here. Okay? Now, something else about the additive law. I'm going to go back now to the whiteboard, because sometimes this book irritates me because it goes around the bush. It goes around the world trying to tell you something. I'm going to put this in red because this is important. 1, always overlap, always subtract the overlap. Overlap means counting something what? Twice, or 3 times, or 4 times. 2, always look for the always look for the word. Always look for the word or. And that's enough for right now. I was going to do a third, but I'll just wait. Okay? Oh, the third, I had a brain bubble. Sometimes it's best to put in a table form. Okay? Now, what are the, since I'm writing in red, so I'm giving you, I'm trying to do 5.2 and 5.3 in 2 pages instead of 8 pages, because they're going to do 8 pages in the book, and there's no sense in it. Okay? With the multiplicative law, the one thing you've got to always remember is whether it's with replacement or what's the opposite of with replacement? Without replacement. With replacement means that it does not affect, you're going to put the marble back in the bag, which means it does not affect the probability, which means it's independent. Without replacement means that it will affect, which means that it's dependent. What I mean? Well, let me just give you an example. Let's say I ask you to pick a marble out of, not a Marlboro, okay, a marble out of a bag. And let's say there's 10 marbles in the bag. Everybody with me? And let's say that there's 3 red marbles, 3 blue marbles, 3 green marbles, and 1 black marble. Everybody with me? What if I ask you to pull a marble out of the bag, write it down, and put it in your pocket? How many marbles are left in the bag? Not 10, but what? So now you're subtracting from 9 instead of 10. And then you put the other one in. That affects, without replacement, if you put it in your pocket, that affects the next outcome. Let's think of it as a deck of cards. Let's say that I shuffle a deck of cards and I ask Mr. Gilliard to pick a card. And I tell him to look at it and memorize it. And then I go to Mr. Smith and I say, pick a card. Is the mathematics going to be different because Mr. Gilliard didn't put that card back in the deck? Yes. So without replacement means that it will affect the next outcome, or it will affect the probability, or it will affect the mathematics because you didn't put the card or the marble back in the bag. Capiche? Okay? Now, that's all you've got to remember with the multiplicative law. You don't really have to, the key word is and. Key word is and. What is the probability of picking a king and a queen? Instead of or, it's going to say and. So on the test, when you do your 6 or 7 questions from this section, these 2 sections, 3 or 4 apiece, okay, you look for the last sentence and you look for the word or you look for the word and. Now we're going to do an additive law. Ms. Blackman, what time is class over? Remind me.
2:35.
Okay, that's good. I just want to make sure it wasn't like, because right now it's going on 2 o'clock. Okay. 2 what?
2:35.
Okay. All right. So let's clear the board and let's go and do an additive law. I like to use the following example because you can do this example and there's like 5 or 6 examples in one thing. RH positive and RH negative. What is this? Miss Blackman?
Blood type.
Blood types. A, B, O, and what's AB? Is that all of them? I think that's all of them. 2, 4, 6, 8, 10, 12, 1, 2. Okay? What's the first thing you do when you're given a table? You figure out what the total is. So figure it. What do? You add up all the numbers. Well, there's a 6 and a 4, so that's 10, 20. There's a 30, there's a 42, 45. Somebody tell me if they get 45.
Yeah.
So our total is 45. So you know right there's your denominator. Okay, now, here's the question. Here's what the question is going to say. Find the probability of A or O type. So what do? Well, you take your handy dandy highlighter. Now I'm telling you the best way to learn this. So if you've already had this and you invented it, then you don't have to follow what I'm talking about. If you've sucked at this before, if you've taken this class before and you really didn't understand this, then you get out your highlighter and I'll show you how to do it. Okay, so we're going to do the probability of A. I'm going to highlight that green. And I'm going to highlight O. I'm going to highlight that yellow, or yellow, depending on where you're from. Cause possibly odd. So, all this probability of A or O type blood is it okay if I say blood? It's okay, right? There's nothing wrong with blood. Okay. A or O is going to be something over 45. And then I'm going to take my green marker and I'm going out of the way because I don't have posters, so I'm going out of the way to kind of match this up. 2 plus 4. Now I'm going to write in yellow so y'all can bitch about not seeing it. So make sure somebody bitches about it. Plus, parentheses, 10 plus 12. Anybody going to do it? I can't see! And then I'm going to put in red, minus 0. Now what's that red for? What do we always subtract? The overlap. Where's the overlap? There ain't there. Okay? That's how you do the attitude.
What do you mean by overlap?
Now you're going to see it on the next one. Where the two colors, where the two highlights overlap.
Like if you said O or positive.
That's what we're fixing to do. Yeah, we're going to do one where it overlaps. So, what's 2 plus 4? 6. 6 plus 22 is 28. And somebody give me 28 over 45 in decimal form. 3 spaces, please. 28 over 45.
It's going to be 0.622.
And that is the probability of picking a A-type or an O-type out of 45 people. So now I got to erase all this. So now I erase it, I got to go backwards because I can't erase it because one, I haven't had training. There. Now I want you to find the probability. The reason I couldn't erase because if I erase the highlight, I have to erase the whole column. So that's why, and I could go in, it's just a lot of trouble. I'm not going to do it. Okay, so the probability of RH negative or AB. So I'm going to take my handy dandy highlighter and I'm going to highlight yellow as my AB. So that means this guy. And then I'm going to take my green, dang old Verde, and I'm going to highlight my RH what? Oh, we got a what? We got an overlap. What? You got overlap right here. We're going to do that in red. I'm going to circle it in red. Now, I'll take my green marker, and I go 4 plus 8 plus 12 plus 2, and I take my yellow marker and add 1 plus 2, and then what do I subtract? I subtract 2, and all that's over what? 45. Now, usually when I show this, before anybody says anything, I usually have some water walker that goes, oh, well, you don't have to do that. All you got to do is cancel out the 2's. Okay? What is my job in this classroom? To assume that you already know how to do stuff, or to teach people that don't know how to do stuff? Teach people who don't know how to do stuff. I'm not in here for the water walkers. I'm in here for the people that don't know how to do stuff. And if I just tell somebody that don't know how to do it, if I just tell them to cancel out the 2's, what's the first thing that person's going to say? Why? Or how? Okay? So it's easier just to teach from the beginning than it is to try to appease the water walkers. Okay? So, and if you say, well, I know why they do that, well, then you do what you need to do. If you suck at this, then you need to follow what I'm doing. So, the probability of RH negative or AB is equal to, somebody give me 3 digits.
0.577.
0.577. And you have just done the additive law. You've got one that overlaps and one that doesn't. And I've tried to teach different ways, and the easiest way is with the highlighters because you actually see the overlap. And if you subtract that overlap, you never will go wrong. Yeah. Okay, that's why I put a 0 in red on the last one. I'm glad to see everybody in here knows how to wear a baseball cap. There's 2 ways to wear a baseball cap. Straight bill and curved bill. I despise straight bill. If you wear a straight bill, you're hiding something. Just like a bow tie. I come up with these things all the time. I do. I like to come up with this kind of stuff. I'm serious. If you ever watch somebody with a straight bill, they got something to hide. All right. Oconee, you agree or disagree, or you think I've lost my mind? Which one is it?
It's all good over here.
I doubt very seriously you have too many people in Oconee that wear straight bills. Usually they're curved. Usually people in Oconee, they go extreme. They have like those curves like this, you know. They're pretty extreme up that way. Okay, I got a cousin that lives up that way, so he's pretty extreme, notorious. All right, so what about the multiplicative law? Well, the multiplicative law is where you're doing something and you have to either put back in or take back out. I'm going to give you an example. Let's say that I give you a bag of marbles, and I'm going to draw this out for you because I want y'all to actually, there's your bag of marbles, and you can say deck of cards, you can say bag, don't split hairs with me, okay? You can say bag of marbles, you can say, cars in a parking lot, whatever you want to call it, okay? And let's say that let's use our colors since I don't have a poster. There's 6 blue marbles. There is 5 red marbles. There is 7 green marbles. And my favorite color, I'm going to pull in the yellow so that y'all can bitch about not seeing it. 5 yellow marbles. So the first thing you do is what? Find out how many in all, right? So 5 plus 5 is 10. If you notice how I add stuff, I always find the 10s. Why? Because a second grader can add 10s. Yeah, that's easy. It's easy math. Some people go through life going 6 plus 5 plus 7 plus, and that's the hardest way to add. 5 plus 5 is 10, and then 13 is 23. So 23 is equal to n. So that's your total. So that's your denominator. All right, now I'm going to ask you, what is the probability of picking 3 blue marbles in a row? And with replacement. And then I'm going to put out here, I'm going to put with replacement. Will the question signify with or without replacement? Yes. The question will say independent, which means with replacement, or it'll say with replacement, or it'll say dependent, or it'll say without replacement. If it's with replacement, then you can do it two ways. You can say 6 over 23 times 6 over 23, times 6 over 23, or you can say 6 over 23 raised to the what? Third power. This highlight means the same as how many you're asking for, or how many you multiply. 1, 2, 3. Either you multiply it 3 times, 3. If that was a 6, you'd multiply it 6 times. If it was a 5, you'd multiply it to the 5th power. You see what I'm saying? Of course, you can't multiply. You could multiply it to the 5th because there's 6. Okay, but the whole point is, if this number, whatever this number is, that's what you multiply it by, or you raise it to. They're the same thing. So somebody takes 6 over 23 and raise it to the 3rd power in your calculator, and give me 3 digits.
0.017.
Make sure everybody gets 0.017, because some people learn how to use their calculator with the exponential. So make sure everybody get 0.017 before we move on, or at least one person get it.
You have a work email.
That's probably them firing me for making fun of their IT. Well, I'm sorry. Some people need to. Did y'all get it? Tell my daughter something. Sorry, she just got home.
You found your phone?
Yes, finally. How'd you know about that?
You know this. In class.
Oh, I can't remember what I tell y'all. I'm sorry. I told her 15,000 times. I said, now, Lauren, let's think about this logically, because she don't believe, Daddy's stupid. She believes Daddy is stupid. I said, I told you that the battery cut off at 2:45, because that's what my phone told me. Her battery cut it off at 2:45. I said, you were in bed at midnight, right? Yes. That phone is in your room. No, it's not. Somebody came in and got it.
She lost it.
All right. Yes, she couldn't find it. Okay. What is it?
I've lost my phone places, but it's not.
Listen, it happens. I've lost my phone in the house.
Yeah, I've lost it in the house before.
Yeah. Anyway, I told her, I said, and then I had $200 cash in my pocket one time. And I thought somebody stole it. Because I remembered I was at this store and I paid for something and I had $180 cash left and I had it at the store. And I went home and the next morning I couldn't find it. And I looked all over the den. I thought it was in the den. Come to find out that I put it in this little compartment right here, and my phone fell off the bed. Okay? Because when you're single, half your bed is like everything, like the bookshelf and the food pantry. And anyway, it fell off the bed, and the money came out, and it was under the bed, and it was behind one of my shoes under the bed. How those dollar bills flipped over a pair of shoes, I don't know. And I told her, I said, that phone is it? No, it's not. No, it's not. No, it's not. Okay. Don't believe me, I'm stupid. And she was at my house yesterday, I think. When did I tell you all this? Tuesday, was it Tuesday? Okay, Tuesday night, she said, I'm just going to have to go get another phone. I said, no, you use one of my phones and wait until the phone shows up. It's not going to show up. Okay? Now you're going to start to see why I got a divorce. Anyway, the whole point is, because she didn't take after me. Anyway, to make the whole roundabout thing is, she was at the Sprint, and while she was at Sprint, her mother called, her brother had said, I found the phone, and guess where it was? In one of her shoes at the end of the bed, in one of the shoes. It fell off the bed. Evidently she was laying in bed or whatever, and she flipped, and I don't know what happened. I don't know. She may sleep in her bed upside down at her mother's house. I don't know. But at the end of her bed, she has her shoes, and she checked in the bed, but she wasn't checking. So I called her, of course, to say, I told you so, and she wouldn't answer the phone. I told her, I said, that phone, look around your bed, look in the boxes, look under the furniture. I didn't know her shoes were at the end of her bed. I said, I would have said that, and she didn't. She focused on the bed. But the whole point is, the logic dictates, Occam's razor says that the simplest idea is usually what? The correct idea, or whatever. I don't know what Occam's razor says, theory-wise. But the most simplest explanation is usually the best explanation. And I told her, I said, that phone is in your room. But when she's one of those water walkers, she knows everything, so that's what I'm saying. Anyway, let's do without replacement. What is the probability of picking 3 marbles, and you're not replacing? Yeah, 3 blue marbles without replacement. Well, all you have to do is start off just like you did here. 6 over 23.
Priority 1 message coming in on secure channel.
But what is the next draw? 5 over 22. Good job. How'd you know that? Are you a water walker? And the next one is 4 over what? 21. I'm sorry, but my daughter is one of these that blows up your phone. She can't write 1 message. She has to write 15 messages. Yeah, see, 5 or 6 messages. They usually turn it on. There we go, vibrate. So somebody do that math.
0.011.
0.011. So did everybody get 0.017 and 0.011? Yes or no? I hope you did, because y'all not saying anything. Okay, you got it. Now, so when do you use what? Well, when you do with replacement, you make sure you use the exponent, because that's the easiest way to do it. Without replacement is a pain, because you have to do, so learn how to use your calculator with parentheses, and just do 6 over 23 parentheses times 5 over 22 parentheses times, make sure you put parentheses around each fraction. And your calculator should do it without any problem. But that's not what I want to show you. This is what I want to show you. Let's change this bag to a BA bag. Who's taking pictures? Okay, nobody's going to talk. Okay, that's fine. And instead of 6 blue marbles, you have 600 blue marbles. And you have 500 red marbles. And you have 700 green marbles. And how many yellow marbles? No sneezing in class. How many yellows did I have? Okay. What?
I don't know, I can't see them.
No. I love when people are smart. Okay, 23. So that's 6. That's 13. 5.
You have 5 yellow.
5 yellow. 500 yellow. Okay. So now we don't have 23. We have 23 what? We got 3 digits over 300, and we've got 4 digits as a total. So let's do the math again. And this time we're just going to add zeros. So take 600, divide by 2300, 600 divided by 2300, 600 divided by 2300, or 600 divided by 2300 raised to the 3rd power. And then down here, we're going to do 600 divided by 2300 times what? 599 divided by 2299, and then 4 and 5 what? 598? 598 divided by 2298. Now this one's not going to change very much. What do you get when you get 600 over 2300 to the 3rd power? What do you get? Same thing. Now do this one. Speak.
It's pretty much the same.
No, it shouldn't be the same as this one.
I got point.
Should be different. Oh yeah, I'm sorry. It should be the same. Yes, you're right. I'm sorry.
598 on the end.
Yeah.
2298. Go ahead. What'd you get?
0.017.
Good. So what can you curtail from 3 digits above 300? Does it matter which method you use? No. And somewhere in your book, it'll say something like that in some way that you don't understand. I usually tell students 3 digits over 300. All these digits are 3 digits, but they're not 199 and 299. They're all over what? 300. When you start with 200 and 199, you start seeing a difference. I did some problems one time, and when you get under 300 on your marbles or your cards or your CDs or whatever you're testing, you start to see a fluctuation between 3 digits. 017, you might get 0.0165.
I got 0. It just rounded.
That's funny. Okay, the first one must have been 0.01752. Was it 0.0175? What was it?
I think it was 0.01775.
Okay. Well, the whole point is they're both around 0.018. And somewhere in your book, I don't know, you could look if you wanted to, and 3, is this 3.3?
This is 5.2 or 5.3.
Yeah, whatever. 5.3. So look in there and see if there's anywhere that it says, and it'd be in a yellow box or a blue box. It'll say something like, after the number, as the numbers get higher and higher, it doesn't matter whether you do with or without replacement. Okay? Yes, no, maybe, I understand, I don't understand. Questions on these 2 sections? Now, I do expect that you send questions to me. And now you should be working on 5.1, 5.2, and 5.3. Do not work on anything in front of me, because I still haven't decided which ones I'm going to omit. I told you I had a feeling which ones we would omit, but I'm not certain yet. You don't need to be in front of me anyway. You should be working on 5.1. Well, actually, you should be working on 4.1, 4.2, 5.1, 5.2, and 5.3. We only got one more section to go over. Which one did I tell you? 5.5? Somebody look in your notes from a couple of weeks ago or a couple of days ago. 1. Do you see it anywhere? Or the actual name of the chapter should be counting. 5.5. 5.5 is our last section. Unless I decide to add the other two. So if you want to go ahead, you can start working on 5.5, but I haven't looked at it yet, so I don't know if I'm going to include 5.4. One of those 5.4 or 5, I think it's 5.4 is the one that I might pull something out of. So, but just work on 4.1, 4.2, 5.1, 5.2, and 5.3. Capiche? All right, now let's take the roll. So we're. Oh, did I start the recording?